Okay, let's get going. Let's get going with revising some function stuff. Where's my bearings? Okay, so first off, let's have a good old parabola and a straight line. Below are the graphs of f of x being equal to x minus 4 in brackets whole squared minus 9, and a straight line G. A and B are the x-intercepts of f and E. So over there. And then E is the turning point of f, right over there, so that's important information. And we have C being the y-intercept of both f and g. Well, that might be important later. The x-intercept of g is d, right there. And DE is parallel to the x-axis, or the y-axis I should say. Okay, reading is very important for me. Write down the coordinates of E. Okay, so we have our function written down in turning point form, which means we take that and that as our P and Q values. Therefore, turning point has coordinates 4 and negative 9, which gels. So you can see here, that's on the positive side, and E is below the x-axis, which means it should be negative. So we have an updated graph. Now they want us to calculate the coordinates of A. Well, turning point form translates into standard form quite easily, and from there we can factorize. So let's see if we can get that out the way. For number 2, we have f of x being equal to x minus 4 all squared minus 9, which turns into x squared minus 8x plus 16, and then minus 9, and that translates into x squared minus 8x plus 7. Let's see if I collect these two like terms. That's f of x, and then for x-int or x-intercepts, we set y equal to 0, so then we'll have x squared minus 8x plus 7 all equal to 0, and that's just x minus 7, x minus 1 all equal to 0. It's in factorized form. Don't be shy, you're allowed to use the formula if you don't see the factors immediately. So yep, that should be a 7. Therefore x is equal to 7, and x is also equal to 1. Those are the two x-intercepts. Well, and it doesn't take a lot to see that. Well, B is further from the y-axis, or further from the origin, so it makes sense that this would have coordinates 7 and 0, and A would have coordinates 1 and 0. Therefore, the coordinates of A are 1 and 0, which is the actual question that was asked. So let's move right along. So let's see if we can transpose some of that detail, or transcribe some of those details. So that was 7 and 0. We also have here 4 and negative 9, which means D has coordinates of 4 and 0. So all of that makes sense. So M is the reflection of C. Well, C is right here. Well, M is the reflection in the axis of symmetry of F. Write down the coordinates of M. Well, let's see what we can do with that first. Okay, so let's just draw a line from D that projects this axis of symmetry further upwards. Okay, I can do slightly better than that. Let's undo that. Okay, from D. Okay, okay, not perfect, but it's not what we are after. So M sits somewhere over here, and if we can have a look, that's C. C sits on f of x, and its reflection should be on the other side of this axis of symmetry, which has this dotted line over there. Now, do we know the distance from C to the axis of symmetry? Absolutely. Well, D is perpendicularly above E, or it's also parallel to the y-axis, so it goes vertically up. So we know that the distance from there to there is 4 units, which means if we go another 4 units, we'll be right on top of the axis of symmetry point for M, or the x value of M, which should be right here. Okay, so M at least has x coordinate of 8, because 4 plus 4 is equal to that 8. And what about the y value? Well, if we previously checked, we had f of x in standard form. So if we can get that back to our current slide, we know that f of x is also equal to x squared minus 8x plus 7, which is that, and that 7 is obviously our y-intercept coordinates. Well, therefore, for number 3, D has coordinates 8 and 7. So that's all based on understanding how symmetry works, how our turning point coordinates function in terms of symmetry, and how that symmetry gets translated across from point to point. Determine the equation of G in the form y is equal to mx plus c. Well, for number 4, we already know that c is also the y-intercept of G, and for that we can take that value from there. So c is equal to 7, and now all we need is to figure out the gradient. Well, we have D and we have C's coordinates, therefore the gradient of CD is just going to equal to y value at C minus the y value at D, and then the x value at C minus the x value at D, and as you can see, that's negative 7 over 4. Therefore g of x has a defining equation of negative 7 over 4 x plus 7, and that gels because we can see we have a negative gradient for that straight line from observation. Now they're asking us to write down the equation of the inverse of G in the form y is equal to something. Well, let's just have a look at these coordinates. So this is 4 and 0, and that is 0 and 7. Now we do know that for the inverse, our coordinates switch places. Our x and y coordinates switch places. So if we can sketch that in, should be able to see something. So that's going to be, well, 7 and 0. That's for switching that set of coordinates. And if we take D, D will become, well, 0 and 4. Now if we just throw a straight line through that, we should have something like that over there. Now that visualization is just for us to see that, well, the gradient should still be negative, but in this case our inverse gradient is going to have coordinate what, 4. So we already know the c value, but its gradient is going to be negative 4 over 7 instead of negative 7 over 4, and of course x, and that's how they can ask us to just write it down. Now next question asks for which values of x. Well, x multiplied by f of x be less than or equal to 0. So they're talking about all x values, and then just f of x's values. So if we have a look at that, and we just do this to delineate x-intercepts for our parabola, we can see that this area is negative. So we know from there to there we have negative values, and then from here on out everything is positive, and then from there everything is positive. I am of course looking at the y values because that is what f of x means. F of x tracks our y values, and then from there on up, and from there to the back, everything is positive for the f of x graph. Well then, how about our x values? Well, the x values are even easier to track. Those are all the negative x values, and these are all the positive x values. So that bit is positive, that bit is positive, and that bit is positive. And what we're looking for is a product, because this is a product. It's an x value times the y values from f of x. Now that product needs to be negative. Now as we can see, this zone is out, this zone is in, because this is where we have a positive multiplied by a negative, and we have those values there. That's 1 and that's 7. And then for the last zone, well, this is positive and positive, so that puts out, and then everything beneath 0 or less than 0 is also in. So what's our answer for number 6? Let's just mark that as 5. For number 6 we have, well, x can be less than or equal to 0, or x needs to be between the values of 1 and 7, with these boundaries being included, of course. And that's the answer to